Hello friends, welcome to this video, and this video is a part of YouTube series Machine Learning and Data Science. Those who are interested in becoming a data scientist, or those who are already an expert in a data science and want to extend their knowledge, this YouTube series is for them. In a last video we have seen two problems. One is a AND gate AND system and the XOR system, and we try to find out the linear separability of the both the systems, and we found that AND gate is a very good system, very good system in the sense it has a linear separability, whereas XOR problem didn't have a linear separability. It is not a it is not a linearly separable problem, but fortunately we there is a way to make that problem linear separable, and we used a feature engineering where we applied some transformation to the inputs of the XOR gate, and those transformed inputs we used as the inputs to the XOR problem, and there that those inputs or those the outputs becomes outputs with respect to those transformed inputs in the XOR problem becomes a linearly separable. Fine. In this video we are going to see the two activities. Now, as we know, we normally have a data, and then we try to find out the linearly separable or the hyperplane, because we have seen that in a one-dimensional data or in one-dimensional problem the constant is enough to have a decision boundary. In a 2D two-dimensional data the line is enough to have a decision boundary, and if it is a three-dimensional data then the 2D plane is enough to have a decision boundary which will separate the two classes in that 3D space. If it is a 4 dimension or higher than the 4 dimension, the problem is of the higher than the 4 dimensions, then whatever the decision boundary we will make a mathematically or by using a machine learning algorithms, we will call that hyperplane. So decision boundary for any dimensions can be called as a hyperplane. So when given a data, and in these slides we have a two-dimensional data, right? So this two-dimensional data, one red rectangle data is, these are the data points, -1 and 2. So two-dimensional data in the red rectangle is a one class is belong to one class, and these data belongs to the another class data. Now with respect to this sorry, with respect to this two set of data, what we are going to do, we are going to find the hyperplane or hyperline which will able to separate out one class from the another class and vice versa. Now let's do two activities in this video. The one is the human, that means I will be deciding the hyperline, and in a second activity we will see how mathematically we can decide the hyperline given data points of two classes. So one is with the human intervention we will solve the problem of deciding the hyperline which will separate out the two classes, and the another, the automatically, the mathematically, or by using a machine learning we are going to solve that. We are going to decide the hyperline which will separate out the two classes. So let's start with the first activity, that is human activity. That means myself will decide the hyperline. Okay, so so we have this data red, the one belongs to the red classes, red triangle, and another belongs to the green circles, and we plotted these 2D points on this graph. Okay, so if it is a -1 2, so -1 and 2. Okay, this is the 1 point. Second is a 0 comma 3, so 0 and comma 3, so this is the 1 point. -1 and 3, so this is another point. -1 and 2, this is another fourth point. The -1 and -1, this is the fifth point, and sixth point is a -2 1. Similarly, green circle data, right? So sorry. So so now here we can see the vicinity, we can see the cluster of two classes. Okay, so this is the one vicinity or the cluster of the rectangles, and this is the vicinity of a green circle data. Okay, now I want to find out the hyperline which will separate these two classes, and it's very easy. I think there is so much gap here, so I can plot I can have a line like this, or I can have a line like this, or I can have a like this. Okay, so there are so many combinations of that, but anyway we need to decide only one. So I decided on that this is the line which will separate the two classes from each other, and I will call this hyperline. Now, so this is decided by me. Okay, and I plotted this. I think this point I have taken, which is nothing but a 2 5, and this is the -2 0. Okay, so 2 by 5 and 0 -2 is are the 2 points on this line, are 2 points on this line. Now we can we have a line equation for this? Okay, and we will know why we are interested in finding the line equation, because normally whenever we have a line, I think we are going to represent it by the line equation, and then how that line equation we will use it for the classification purpose, we are going to see that very soon. So line equation with 2 points, because this is the line and we have a 2 points on that. So line equation with 2 points can be given as a y is equal to mx plus c, where m is a slope and c is the y-intercept of that line. So y-intercept is nothing but this line is crossing the y-axis at this point, that means a -2. And slope we can calculate because we have a 2 points, so y2 minus y1 divided by x2 minus x1, that means 5 minus -2 7 divided by 2 minus 0, so 7 by 2. So slope is going to come as 7 by 2. A c, that means intercept, y-intercept is going to come as a -2, right? And when we put these two values in this standard equation, we get y is equal to 7 by 2 into x minus 2. If we multiply by 2 to the both sides, you get a 2y is equal to 7x minus 4. And if you bring this right hand side to the left hand side, 2y minus 7x plus 4 is equal to 0. So now this is going to be a equation for this line, and this line is nothing but the hyperline which is separating these two classes. Now let's test, because we got this hyperline equation and we have this data. So let's see how this line is useful in separating these two classes or any points near to these points. Okay, so we are right at this moment, we are not taking any other points, any points other than the given points. Okay, by which by observing these data points, we decided the hyperline and we got a hyperline equation this. So -1 comma 2, put here and solve this equation, that means solve the value of that equation. So -1 is x, so put here, and 2 is y, So put here and solve this equation. Sorry. So 2 into 2. Now if I put a 2 is a y, so 2 here. So 2 into 2 and 7 and x, so x is a -1. Okay, and then plus 4. So 2 into 2 is 4, minus 8 means -7, means -7 into -1 means it will be +7. So 4 plus 7, 11 plus 4, 15. So that's going to be there. Now similarly solve for this 0 and 3. So 0 is here and 3 will be here. 2 3s are 6, 6 plus 4 10. This is going to be 0, 10. 2 into 3 6, 6 plus 7, because 7 into -7 into -1, so 6 plus 7 is 13, 13 plus 4 17. 2 into 2, this -1 will come here and 2 will come here. So 2 into 2 plus 7, 7 plus 4 11, 11 plus 4 15, 2 plus 1 plus 7 9, 9 plus 4 13, 2 plus 14 16, 16 plus 4 20. Let's do the same thing for the green classes points also. So 3 and 5 put here with the 7 and 5 will come with the 2. Okay, so 2 into 5 10 minus 21, so minus 11, and minus 11 plus 4 minus 7. 2 into 4 8, 8, 8 plus 4 12, and this is 21, so minus 21 plus 12 will be -9. Now 2 into 4 8, 8 plus 4 12, 12 minus 28. Okay, that's going to be -16. So similarly you can solve for this and you will get a -16, -25 and -23. So what we observe here, the one class, when the hyperline which is visually separating the two classes is solved for these points, it's solved for the one class, one data points of the one class gives a all the positives, and another side points, if used to solve this hyperline, will be negatives, and third will be actually the points, data points which are actually on the lines will give a 0, right? That's why that the equation is of the line is, right? So we can conclude that sign of hyperline solved for a particular data point decides the class to which data points belongs. Okay, so the sign, so we this hyperline is you know, if we solve any data points for for this equation is solved for any data point, then its value will decide that data point belongs to which class. Now again remember, this was done with the human intervention. That means the line, which line it should be, I had many choices and I selected one just by randomly, and then I think I decided that, so it was a human intervention and we got a hyperline. Now can this hyperline be decided without human intervention and can be decided by mathematically, and which is nothing but the kind of the ML algorithm. So we will have a data, we will do computations on that data and we will decide the line, and then once we decide that hyperline, we will again test this way that whether that hyperline which is decided by the mathematical algorithm satisfies this kind of, you know, satisfies the this kind of separability for red classes and green classes data, right? So now we will decide the hyperline for classifier using MLBase. Now here My just I think it should have been told earlier that that the notations have been changed now on this graph, because normally we before this video we used to take two inputs or three inputs or two dimensions as a x1 and x2, three dimension as a x1 x2 x3. Okay, but in for the sake of the this video explanations, we are changing that notation from x1 x2 to x and y, so that's why x here and y here, and that is the same case was in the earlier human activity also. Well, so let's formulate the computational procedure for deciding the hyperline given this two classes data. So we have a two classes data. Take a centroid of this. Centroid is nothing but -1. I mean, take these coordinates of all the data points, sum them up, and then divide it by number of points, which is 6. So -1, -2, -3, -4, and -6. So -6 and 6 points, so divided by 6, it is going to be -1. 2 plus 3 5, 5 plus 3 8, 10, 11, 12, and 12 divided by a 6 point, that means 2. Okay, similarly green side also, 3 plus 3 6, 14, 14, 19, 24. 24 divided by 6 is 4. 5, 4, 9, 13, 17, 20, and 24, and divided by 6 is a 4. Okay, so we got a centroids for each of the class data points. Okay, so this is a one centroid, the red triangle, big triangle, and the red green bigger circle is another centroid. So we got these 2 points here, and then we connected these 2 points by one line, right? Which is nothing but the centroid. I mean, let's call it by a centroid line. Okay, this blue line is a centroid line. Now when you have these two centroids, take a midpoint of this on this line, and that's going to be a -1 plus 4, which is going to be 3, and these are the 2 points, so average mean point, so divided by 2, so 3 by 2. Okay, and 2 plus 4 6, 6 by 2 is equal to 3, so 3 by 2 comma 3 is going to be a midpoint of these two centroids on this line. Okay, so we have to draw one perpendicular line. This yellow line is shown here. This perpendicular line will be the best hyperline which will separate this side with this side, okay, from this side, and that's why make sure this is perpendicular here. That means yellow line and blue line is perpendicular, and the yellow line is passing through the midpoint of these two centroids on this line. Okay, that means our yellow line has got yellow line. I mean, what are the known parameters for this yellow line? Is a 1 point is on that is 3 by 2 comma 3. And second thing, we might need a slope for this. Now can we find out the slope for this? Yes, because these two lines are perpendicular to each others, and that is why the slope of these two lines, that means product of slope of blue line and slope of yellow line will be always -1. Okay, so that's a theorem. I think you can check it on the on internet, but that's a theorem that when the two lines are perpendicular, product of their slope will be always -1. So now we can find out the slope of this line if we know the slope of this line, and this slope of this line can be find out easily because we know the 2 points on this line. So what will be the slope? Y2 minus y1 divided by x2 minus x1. So you take a point, this point as a first point or the second point, it will not matter because we are dividing the two things, and then their sign will whatever the order you take, it will not affect. So 4 minus 2, that means 2, and 4 minus 1, so 5. So 2 by 5 is the slope of blue line. What's that? 2 by 5 is the slope of this blue line. So I can say the slope of this line will be minus 1 divided by slope of this line. So minus 1 divided by 2 by 5, which is nothing but the minus 5 by 2. So yellow line will have a minus 5 by 2 slope. Now once we have a slope of this line and one point of this line, again there is a standard equation of the line if we know the one point on that line and slope of that line. So that's called the point slope form of line equation. Okay, so that is how we are going to get the equation of hyperline. Okay, so hyperline, so let's we have discussed so far. Now we will just go step by step. So what we are doing? Hyperline, that means LO1 is perpendicular to the centroid line. So slope of the hyperline is equal to minus 1 divided by slope of centroid line. That is a theorem. That is a proven theorem. We know 2 points of centroid line, its slope is 4 minus 2 divided by 4 minus 1 is equal to 2 by 5. So the slope of the hyperline is going to be minus 5 by 2. We know standard point slope line equation, that is y minus y1 is equal to m into x minus x1, where x1 and y1 is nothing but this point, so 3 by 2 comma 3, and slope m is equal to 5 by 2. So actually it is a minus 5 by 2. Okay, that's a let me make it minus 5 by 2. Anything else, and this minus 5 by 2 we put here as it is. Okay, fine, perfect. So m is equal to minus 5 by 2. So y minus 3 is equal to minus 5 by 2 x minus 3, because these values we are putting in this standard equation. So we will get a y1 is nothing but the 3, okay, and x1 is nothing but the 3 by 2. So y minus 3 is equal to minus 5 by 2 into x minus 3 by 2, and which will imply 4y minus 12 is equal to minus 10x plus 15, and this will give us a 4y plus 10x minus 27 is equal to 0. This is the line equation of the hyperline. Now let's test the same way. Let's test this hyperline which we got a mathematical procedure, and there is no human intervention. Simply we have done some calculations on the data points, data points of the two classes given to us, and then the algorithm has reached to the equation of this hyperline, which is able to separate those two data point classes. Okay, now if we put again these equations in this one, if we put these data points on this equation, or we solve this equation for the red classes data points and the green classes data points, we are going to get these values. This is all the negative values, and this is all the positive values. Okay, these are all the positive values and all the negative values, and this implies that this hyperline equation is really able to separate these two classes data points from each other. Okay, So that's how it's a very important to remember here that whatever the hyperline equation we got, it was not decided by with the human intervention, but it is decided by the mathematical calculations, or simply we can say a simple ML algorithm we use to decide that. So in a conclusion, the sign of the hyperline solved for particular data point is able to decide the class to which the data point belongs to. Okay, so hyperline, again remember, hyperline determined using ML, right? So this is a starting of the machine learning. This gives you the essence of the machine learning, where automatically without human interventions you are trying to solve the problem. Okay, so that's it for this video.